My name is Johann Klages and I'm a marine geologist at the Alfred Wegener Institute in Bremerhaven, Germany. I study the Antarctic continental margin, where I try to reveal the ice sheet and climate history of the icy continent from thousands to millions of years. In 2017 we set out with our icebreaker Polarstern and a special seafloor drill rig that enabled us to recover enigmatic sediments that had remained inaccessible until then and would allow for unprecedented insights into the climatic history of our planet. It's past super greenhouse climates that we need to fully understand in order to better assess what may lie ahead of us if carbon emissions remain unchanged. The mid-Cretaceous period, 90 million years ago, hosted the most extreme greenhouse climate of the past 145 million years. However, so far no records from near the Earth's poles were available, thereby preventing us from understanding the severity of global climate conditions during this period of extreme global warmth. Finally, we drilled into yet unexplored Antarctic sedimentary strata in an area that was repeatedly covered by Antarctic ice for millions of years and which is situated in more than 1,000-meter water depth today. The unique drilling system that has not been applied in Antarctica before unearthed pristinely preserved remains of a temperate rainforest that existed only 900 kilometers away from the South Pole. Mild temperatures and diverse vegetation illustrate environmental conditions unexpected for those highest latitudes with more than 4 months of polar night darkness. We bring down the wall that restricted our view of the severity of global climate conditions during phases of peak global warmth and reveal the significance modern ice sheet presence has for buffering future climate runaway. This knowledge is not only indispensable for evaluating Earth's past climatic extremes, but also for calibrating and improving numerical models that ultimately try to predict Earth's future climate as reliably as possible. Comprehensive high polar latitude data constraints like ours are still extremely scarce and therefore of highest value for informing numerical climate models. However, if such models cannot simulate past conditions convincingly enough, they also won't be sufficient to reliably predict future changes. So far, we can only make very limited inferences of continent-wide environmental conditions in Antarctica during the mid-Cretaceous supergreenhouse, particularly in regard to dynamic interactions between atmosphere, ocean and land masses. However, it's about deciphering those interdependencies that have profound consequences for understanding global climate dynamics in a greenhouse. At the moment, we are therefore developing an advanced Earth system model that, for the first time, will enable us to understand the ensemble of environmental conditions that facilitated and maintained the climate we reconstructed near the South Pole for the warmest interval of the past 145 million years. This knowledge will significantly help pave the way for more accurately assessing climate dynamics in a future high CO2 world.